Welcome to the Resilience series. I'm Stephanie Weaver, the author of the Migraine Relief Plan and the upcoming Migraine Relief Plan cookbook. And for that project, I'm conducting a series of interviews on the topic of resilience. My guest today is Dr. Rami Burstein. Dr. Burstein is a John Hedley White Professor of Anesthesia and Neuroscience at Harvard Medical School and the Vice Chairman of Neuroscience Department of Anesthesia, Critical Care, and Pain Medicine at Beth Israel Deaconess Medical Center in Boston. Dr. Burstein's lab has made significant progress in understanding how migraine disease alters the nervous system. They investigate the neurobiology behind migraine triggers and, in recent years, the physiological basis of light and touch sensitivity in some migraine patients. Welcome, Dr. Burstein.
Thank you. Pleasure to be here.
How did you end up researching migraine? It's more common for neurologists than anesthesiologists to work on migraine. Isn't that correct?
Well, I'm a neurophysiologist, neuroscientist, and I started my career studying pain in general, and maybe more specifically how pain make you lose the will to live at a certain point, and the suffering aspect of pain. And it is through this part that I ended up in the world of migraine. Without any particular reason. I don't have headaches, I don't have migraine, nobody in my family had it. It was a field that was all open because it was so unexplored in the late 1990s that there was a huge opportunity there to step in and make a difference.
That's wonderful. So let's move on to photophobia. So
Yeah,
explain to us what photophobia is, what's the mechanism behind it, and how common is it?
all right. So there are, for the definition of photophobia is evolving. In the past, it was really simple. It was light that make the headache more painful. This kind of photophobia we can explain today. It is caused by light signals that reach the eye, leave the eye along the optic nerve, and converge on neurons in a part of the brain. It's called the thalamus. Converge on neurons in this part of the brain that are active during migraine. And when light signals are added to there's another stimulus to the activity of these neurons that are activated during migraine, it dial the gain up, it increase their activity. And when they are more active, they send more signal to the cortex, and our perception is that our headache gets more painful, more intense. This is the most fundamental understanding today of what is the mechanism of photophobia. This pathway was not known until 2012. In 2012, we discovered there is a direct connection between light signal that leave the eye and neurons that are active during migraine that can explain why light sensitivity or photophobia only happen during migraine. It doesn't happen during other headache. It doesn't happen when you have a toothache or an earache or a corneal pain or trigeminal neuralgia or any other pain in the body. It only happens with migraine. But the definition of photophobia in the last 5 years evolved to be a little bit more complicated. We know that some people, the majority of the people, define photophobia when they're asked about it as light that makes the headache more painful. And if they go to dark room, they feel better. The headache intensity goes a little bit further down, not always. But a large number of migraine patients don't testify, don't have the experience that light make the headache more painful. They testify that light is aversive, that it's simply unpleasant, that they don't want it, and it makes them feel worse, but it's not more painful. And feel worse took us a long time to look into that and understand it. Feel worse means it gives rise to a whole host of negative emotions. It causes anxiety, it causes stress, it makes them unhappy, it makes them angry, it makes them sad, it makes them cranky, it gives rise to a whole host of negative emotions. and it gives rise to unpleasant autonomic sensation like shortness of breath, lightheadedness, dizziness, tightness in the throat, tightness in the chest, like things that really comes anxiety, increased blood pressure, increased heart rate, just the perception that they have it. These autonomic things or autonomic functions, really you can group it under one word, and that is aversion. They are aversive to light during migraine. Without the light, make the headache more painful. The explanation for that is that light signals reach part of the brain that regulates autonomic and affective status. So it regulates autonomic functions. So it tell different parts of the autonomic nervous system what to do, and you get this shortness or tightness of your throat, shortness of breath, a whole host of things like this, nausea, and it also plays a big role in the regulation of emotions. And so all these chemical pathways, it trigger an unpleasant set of negative emotions, and unpleasant autonomic reactions. So photophobia is light that makes the headache more painful and light that is aversive. The explanation to both of them is completely different in terms of which parts of the brain mediate.
Thank you. So, very complex. And those of us who experience photophobia, I think will appreciate understanding a little bit more what's going on inside our brains after hearing that, because it's very complex to research as well. So, you've been working on a project to develop a green light therapy. Can you tell us how it helps and
Yes,
how it works?
yes. So I have to start 2 steps earlier, otherwise it will be out of nowhere.
Okay.
So years ago, I trying to understand better photophobia and what is the role of the optic nerve in this of vision. I studied only migraine patients who are blind and found out that there are two groups of blind patients. There are patients who have no more optic nerve, so they have no perception of light, doesn't matter what. And for them, light never makes the headache more painful. And then there are blind patients where the optic nerve, the nerve that sends signal from the eye to the brain, is intact, but the retina, the receptor that detect light in the eye, degenerated. These patients are blind; they cannot form images. So that if they look at someone, they can't see face, but they can see a shape. They basically can see light. It's called light without sight. It's like if you close your eyes and somebody turn on and off the light, you know whether it's light in the room or whether it's dark. This is what they see. These patients, when you turn on the light makes the headache more painful. And as we studied them further, we discovered that it is only the blue light that makes the headache more painful. Took us a few years to understand what is the mechanism for that. That was okay. At the end of this process, when I published this paper in Nature Neuroscience, there was almost 7,000 websites that went out within 48 hours to advertise glasses and contact lenses that block the blue light. And I stood there with the BBC and NBC and CNN and the NPR and said to them, wait, it's only true for people who are blind, but 36 million Americans are not blind. And for them, blocking the blue light will not make any difference. So at that point, I became interested in the question of whether color has any role in photophobia. So I started in 2012 another study that lasted almost 7 years. And at the end of this study, what I found was that all colors of light beside green make the headache more painful. They expand the area of the head that hurts, they make nausea worse, throbbing worse, they make the headache more painful. In contrast, green light made the headache less painful. and cleared negative emotions and cleared unpleasant autonomic responses, did a whole host of things that are good. But there is a trick here. It's not a regular green light. A regular green light is so wide in its range that it activates a large number of the receptor in the eye that can detect blue and a large number of receptor in the eye that detect red. So in order to escape them, I developed a lamp that has a green light that is so narrow that it only activate the receptors in the eye that detect green, and it does not activate anything that detect blue or red. And this is the trick. So I so why first how it works. Green light generate a significantly smaller electrical signal in the eye, in the human retina, if you compare it to the signal that come from blue and red light. Blue and red light generate a signal this big. Green light generate a signal that is this big. Yet it gives us the sharpest acuity in vision because of the way the human retina, the human eye is designed. Now, green light generate a smaller electrical signal in the human eye and the human brain to the extent that it creates a calming effect on the brain. And as you realize, the human brain is hyper-excitable. It's too excitable. It fires too much and too early and too easily. The green light just tame it down. It calms down the brain activity. So if you want to put it in the big context, the big context is it's really phototherapy. It is non-invasive. It has no risk. It is just a small fraction of the regular room light that we're exposed to all our life, and it has no unwanted side effect. And in the studies that we are doing, it seems to work really well for terminating migraine. For this, you need to spend 2 hours in the green light instead of in the dark. And if you use it every day for 1 or 2 hours, it can reduce the total number of migraine attacks that you have. So the principle behind it is that it should be able to replace dark with two things. You replace dark with light that is good enough to let you read and write and socialize and do the dishes and do the laundry and read to your kids and play around. And it allows you, the brain thinks that you're in the dark while you're in this green, but you can see and you can function. So it can save you the need to quit what you do in your daily life and go into social isolation where you feel like you're missing on life.
Very good. So, so this series is for teaching people how to build resilience in their lives. So, how can a tool like the green light therapy build resilience in patients who have migraine?
This is the green light. It is really a simple thing. If you don't have a migraine, you turn it upside down and become a regular room light. If you have a migraine, you turn it and it becomes a green light. It lights up. If you put it up, it lights up the entire room. And I think that for people like me, who, because I studied, I spend hundreds of hours with it by now in a room that is all green. You get used to it and you stop paying attention that you're in a room that is green to the extent that it becomes so comfortable that I believe that if people spend more time in this green light, the resilience will come from two things: from the fact that they no longer have to quit what they do, which is a huge burden on their life. This is why, along the FDA, a most bothersome symptoms of migraine is photophobia, phonophobia, and nausea. Number one. Number two, it is If you use it long enough every day, it will work as prophylactic. It will begin to reduce the total number of migraine attacks that you have. That's all in the public domain in peer-reviewed journals. That's number one. Number two, it has two more things that contribute to what you call resilience. Number one, anxiety. By far, the most dominant or the most impressive part of using the green light is how easily it reverses anxiety and it transforms patients into using words like it's calming, it's soothing, it's relaxing, it is associated with happiness. It it is by far the most common feedback I get from physicians and from patients, saying maybe because it is relaxing them so much their headache goes away. But nevertheless, the anxiolytic part of it, the reverse of anxiety, is seems to be the most common effect that we get as a feedback from the whatever almost 5,000 people are using it by now around the country. That's number one. Number two, if you use it for 1 or 2 hours before you go to sleep, it makes you fall asleep much faster, wake up less number of time during the night, and sleep more. And if you do wake up, you fall asleep faster. So if you think about reduce anxiety, improve sleep under this green light, this is resilience. You're dealing about the global well-being of the individual. So if it reduces the headache, if it help them terminate the headache, help them to function better when they have a headache, help them reduce the number of migraine attacks per month, help them be less anxious and sleep better, this is under one umbrella of resilience.
Very good. And also, I would add that having tools like that, I think, builds agency, the feeling that you have something you can do to try, and you're not just at the whim of these attacks that just show up randomly, seemingly for no reason.
And uh, and given the price of migraine medication, how much patient pay for one attack, uh, as I put it together, and I'm at Harvard and I'm not trying to make money, I'm trying to make a difference. We priced this one at $150 and it should last you for 15 years. And now we have a desk lamp that costs $89 because I'm trying to get as cheaper as possible, uh, so that one day I make enough money to give it for free for anybody who cannot pay for it. And it's really simple. It is you can take it with you in your backpack or wherever you go. And if you think about $150 for 15 years, that's about $15 a year. That's 3 cups of
I have
coffee.
one last question for you.
Sure.
So, you're a very busy doctor. In fact, we had to reschedule this today because you were called to the clinic, and that's why you're still wearing your mask. You're going back to the clinic. What are some self care resilient strategies that you personally employ to take care of yourself?
Of myself,
Yes.
exercise for 2 hours every day, and eat right and sleep right, and and try to do the best under the current reality in the United States.
Thank you so much.
Yeah, it's what we tell patients: exercise or exercise, eat right, and keep a balance on your life.
Very good. Dr. Burstein, thank you again for being here today and sharing your research. As someone who is sensitive to light, I appreciate your work very much. Check out other episodes of the Resilience series on Facebook Watch, IGTV, and YouTube. And follow me at SWeaverMPH on social media to learn more about my upcoming book, The Migraine Relief Plan Cookbook, which is due out in spring 2022 from Surrey Books. Thanks for
Sure.
watching.
Thanks.
Thank you.